Hello, I'm Chase Tuggle. Today, I'm going to be teaching you guys some calculus, specifically optimization. That sounds like a big word, but all it is trying to find the maximum and minimum values of something. For example, trying to minimize the cost of making something, or trying to maximize the area of something. For example, find two positive numbers whose sum is 5, and whose product is a maximum. So we have here x plus y is 5, and x times y is a, which is the maximum. So for this one, since it's 5, we can just make a chart since it's very small. Find two numbers who adds up to 5, positive numbers, and we find the product and see which one's the biggest. So 1 plus 4 is 5, and 1 times 4 is 4. 2 plus 3 is 5, and 3 times 2 is 6. 3 and 2 and 6, and 4 and 1, and it's 4. So from this, it's very easy to see that 2 and 3 are 2 and 3 add to 5, and their product is 6, which is the biggest. So your answers are 2 and 3. For this one, however, you can't do it because it is a big number. Find two positive numbers whose sum is 750 and whose product is a maximum. So like I said, you can try and make a chart. That'd take you a very long time. So we have to use some calculus for this one. So first, we have to solve for x or y. I personally like solving for y. So we subtract x from each side. So y equals 750 minus x. From that, we plug that into here. So x times y, which is 750 minus x, equals the maximum. So that gives us 750x minus x squared gives us the maximum. From there, we must take the derivative. And in case you don't know what that is, simple shortcut is nx to the n minus 1. Now, for example, x squared, the derivative of x squared is 2x. Because you take n times that, which is 2x to the 2 minus 1, which is 1. 2x to the 1, or just 2x. Now, we do that to this one. 750, 1 times 750, 750. X to the 1 minus 1 is 0, so it's just 750. Minus 2x, just did that one. And this is just a constant, so the derivative of any constant is 0. So now we can solve for x. 750 equals 2x. Divide both sides by 2, we discover that x equals 375. Now we can go back up here and find out what y is. So 375 plus y is 750. 350 minus 375 is 375. So from that we discover that y is also 375. And 375 plus 375 is 750. And if you multiply them together, you get the biggest number possible. For the last one, the sum of two positive numbers is 84. What is the smallest possible value, or the minimum, of the sum of their squares? So we have x plus y equals 84, and x squared plus y squared equals the minimum. So once again, we solve for y. So we get y equals 84 minus x. Plug that into here. X squared plus y squared, which is this squared, and to make it easier, I'll write it all out. X squared plus 84 minus x times 84 minus x equals the minimum. So we have x squared plus 84 times 84, which is 7,056. Minus 84x minus 84x, which is minus 168x. X times negative x is still x squared, so plus x squared equals the minimum. We can add x squared plus x squared, so we get 2x squared plus 756 minus 168x equals the minimum. Once again, we take the derivative. 2 times 2 is 4. X to the 2 minus 1, which is 1, so there's 4x. That's a constant, so it cancels out, or it becomes 0. Minus 168 x to the 0, or just 168, equals 0. This is also a constant. So we solve for x. For x equals 168. We discovered x equals 42. And if we go back in here, 42 plus y equals 84. Discovered once again, y is also 42. And finally, we plug these into there and see what it gives us. So we get 42 squared plus 42 squared, and that gives us 35/28, which is the minimum of x plus y equals 84, which is the minimum of these two numbers that gives you 84 squared. And that's all for today, and tune in next time, and we will do more advanced problems of optimization.